the Osmo Pocket 4P just walked into our lab, and it did something that no other camera has done in over 70 lab tests.
It retains very high amplitudes at very high frequencies. Means this is a superbly detailed 4K image. I mean, how good can it get? I've never seen this. We tested, 70 cameras so far. This I have never seen.
That's the Pocket 4P and its LOFIC sensor technology. So where does it land in our camera database rankings?
The latitude result will be second behind the Alexa 35. So a proper cinema camera can still beat this device.
Barely. And what about its head-to-head rival, the Insta360 Luna Ultra? A very different story.
But it's a complete washed out, noise-reduced to death image where nothing is left in the image in terms of resolution.
Both full lab tests out now on CineD.com and discussed here with Gunther Machu. Let's dive right in.
This is Focus Check, the weekly Cinetech podcast.
Welcome to episode 127 of CineD Focus Check podcast. It's my honor to welcome Gunther in our podcast studio again. Hi, Gunther.
Hi.
And the audience already knows when you're here, it's serious business.
Serious business.
Because we are either talking about a roundup of lab tests or we talk about a specific new lab test that's worthy of a video. And today we're focusing on those two little things, the Insta360 Luna Ultra and the DJI Osmo Pocket 4P.
Yes.
Which, as we all know, we've reported about it many times before, are going head-to-head in the market. And today, the day of the release of this podcast, is actually finally the day, I can't believe it, where the full embargo on the Osmo Pocket 4P has been lifted. Now, everybody and their mom already kind of knows all the specs of this because it has been released in China and Asia before. But we were also under embargo. We were not allowed to talk about more than the fact that it has 17 stops of dynamic range and so on, what they claim.
Yeah.
Up until today. But today we're free to talk about it, and that's why we are releasing lab tests for those two cameras. Now, before we dive into the results, let's talk a little bit about first the devices themselves, but also why so far we haven't tested so many fixed lens camera devices, I would say, like drones and so on. But so far, we've always focused on interchangeable lens cameras, mostly full frame or Super 35 sensors or Micro Four Thirds. And this category of cameras so far has kind of been omitted. Yeah, maybe you can talk about the challenges that we had there.
Sure. Yeah, I mean, basically, there's two major issues with those cameras. They typically have a very wide camera. In this case, we talk about 20 millimeter equivalent. And the tele option is around 60, I think, for both cameras. And a wide camera, you have to put it very close to the xylar chart. And if you put it super close to the chart, there is a big risk that you get reflections from the bright patches of the chart into the dark areas, and that skews the results. That was the one thing. And the second thing is that a lot of these devices also have some sort of computational image enhancements ongoing. A recent example was the iPhone 17 Pro that we also had in our lab, but we never published the results because depending on how the iPhone interprets the scene, even if you put those devices to manual mode
and log,
exposure fixed, everything fixed. Nevertheless, the iPhone itself, for instance, would try to recognize the scene, try to judge the dynamic range, how many bright areas are there, and then computationally tries to balance the image. And that skews all your results because the problem then is there's no fixed point that you can rely on. And we had the situation, believe it or not, we shifted the iPhone to 1/25 seconds of a shutter, log 2, Apple log 2, manual settings, and still, depending on where we put our finger to focus, I tap on the xylar chart, if you put it to a bright patch or if you put it to a medium patch, the results would change, the waveform would change its shape. And we talk about 3 stops of difference, just depending on where the iPhone thinks it should put the exposure, although you are in manual mode. And this way you can't run a lab test. It's impossible. And maybe we show this result at one point just to explain to you what the issue is. But fine, these two devices are different in the sense that they offer these two type of cameras like the iPhone, but also in manual mode, everything is fixed. So at least there's no like scene-dependent computational algorithm at play that tries to balance the image although you're in manual mode. And that is a big advantage of these two devices. So we just, under brackets, had to figure out this issue of the wide camera, getting all sorts of reflections. And here, a big thank you goes to Florian, our dear colleague,
who's sitting behind the scenes.
Sitting behind the scenes, who tried his best, like to put a matte box on and all sort of things. We put the camera asymmetrical a little bit to like don't have the reflection symmetrically on the dark spots, all these kind of things, and eventually figured out a way to do it. But still, you can see in the results that there's a bit of a reflection also on the shadow side, but that's fine. I think we can live with that.
Yeah, and of course, before we dive into the results, I mean, the one reason why it was interesting is simply mostly the claim by DJI of the 17 stops of dynamic range. But before we dive into that, let's talk about the products as a category themselves. It's almost, the rivalry between DJI and Insta360 has become notorious. Just as a reminder for the audience, they've started suing each other, with DJI, basically suing Insta360 over patents, over inventions that they say they made, and then Insta360 had started to employ people that used to work for DJI. So it's all about, like intellectual property and all that. It's really, really nasty. I mean, we're not lawyers, we can't dive into that, but on the surface, I think we can agree, if you look at the Luna and you look at the Pocket, not just the 4P, but in general, I mean, DJI has pioneered this. I think the first one came out, 5 years ago or so? 5, 6 years ago, maybe even 7 years ago, but it was a while ago. And I mean, it's clearly in so many ways just a copy of what DJI has been doing. So it's staggering actually how much of it is similar or the same, even down to details like those accessories and how the screen rotates. Of course, it has some things that are different. You can remove this part and so on, but still, I mean, to me at least, it seems like almost like a staggering rip-off in many ways. Yeah. What do you think?
Yeah, absolutely. I mean, I think the DJI Osmo Pocket is an incredibly popular device. You see it all around the place if you walk around. So I think that's a very heated market, and obviously competition shows up, but it's not so nice. I mean, if it really more or less copies the original product, but okay. I mean, the lawyers will have their take on it.
Hopefully decide,
Yeah. But nevertheless, I think it's very interesting to have two of these contenders now in this market that were just released.
For us users, it's always great.
It's always great.
Competition is good.
Yeah. Competition is always very nice because both of the parties, of course, try to give their best. And we can really see that these devices have been massively improved over the past. And this is what we're going to talk about today. And especially this claim of DJI's 17 stops of dynamic range, that's a bold claim. That's a very bold claim. And typically, those claims never hold up.
Exactly. I mean, very rarely.
Safe for companies like Ari.
Yeah, exactly. The only exception so far.
The only exception so far. But should we spoil something? No. Let's get into it.
Let's get into it. So, backstory here, the DJI seems to be one of the first companies to use a technology called LOFIC, which is
lateral overflow integration capacitor.
Okay, sounds like something from Back to the Future.
It is.
Basically, and you're the engineer here, the way I understand it, it's basically not doing combinations of exposure like we have with these dual gain technologies that we now have in a lot of cameras, which always results in double the amount of rolling shutter and so on. This is not the case here.
No.
What this LOFIC technology seems to do is it literally recognizes the brightest and the darkest spots in an image and treats them differently, but at the same time, during the same exposure without actually having any influence on the rolling shutter results, right?
Yeah, I think these integrated capacitors basically store the charge where the highlights are clipped. And so obviously that gives a gain of about 2 stops in the highlights, as we also could see from the DJI Osmo Pocket Pro, 4 Pro. And this LOFIC technology is really amazing. I mean, it basically means you retain a very good rolling shutter and still have lots of capabilities in the highlights. And then, of course, you can move the whole image and the midpoint, the gray point, and so on to an area where you can sort of have these additional reserves in the highlights, but still have a good performance in the shadows. And that's exactly what we see here. So we have to say, though, this LOFIC technology sensor only is in the wide camera so far, 20 millimeter of the Pocket Pro 4 Pro.
We don't have confirmation from DJI about this, but this seems to be a sensor from a company called OmniVision that was released in April. And there is also, we reported about it, a Sony LOFIC sensor in development or actually released for smartphones with a smaller diameter. I heard that that's interesting, by the way, the diameter of this smaller version that's really intended for smartphones is exactly the size of the sensor in the tele camera of the 4P. So theoretically, in the future, they could use the Sony LOFIC sensor also for the tele, right? So, because one of the challenges is when you shoot with the Osmo Pocket 4P, in order to use the full quality of the wide sensor and those 17 stops of dynamic range that they claim, you have to shoot in a new log format called D-Log2, which is not available on the tele's cameras. In practice, I think the way right now it's implemented could be enhanced because you basically have to, and that's actually what DJI representatives also kind of recommended to us when I was invited to their press event in Malta. You can't switch, like as soon as you set it to D-Log2, then it just tells you when you want to switch in that mode to the tele camera, it just tells you D-Log2 is not available and it doesn't even switch, right? It's not that... It's
not very convenient.
It's not very convenient. So the workaround is to set up a shortcut, like because you can have user shortcuts to different modes, and you press the other button, then it switches to the other stored custom setting, and then you basically back to D-Log, and then you can switch. It would be more convenient to do that. But it's just a way of implementation that's a bit quirky, in my opinion, but they can easily fix that. Anyway, so let's talk about the results. So 17 stops, Gunther.
Just quickly, because of the 17 stops to the Sony sensor that you just mentioned, it claims 100 decibel of dynamic range. And if you convert this logarithmic value to stops, you get around 16.6 stops. So it seems to be on par with the wide camera that we have in the DJI Pocket Pro.
So actually, we can expect smartphones to have amazing performance very soon too. But let's talk about the amazing performance we got out of this. I mean, let's spoil the beans.
Yeah. So the very first thing we always do is a waveform plot. So we set up our Xyla 21 chart, and if you don't know how it tests dynamic range, please have a look. We always put a link in all the articles to the original article where we explain that. And what it has is basically, it's a chart that has 21 patches with different brightness covering 21 stops of dynamic range. And the very first thing is always we set the cameras up, despite all the difficulties we had, and we look at the waveform plot. And Nino, have a look on my screen. You can see the waveform plot of the wide camera of the DJI Osmo Pocket 4 Pro.
Yeah, so we see an amazing... Staggering 16 plus stops
of dynamic range
with almost no noise, a very low noise floor.
It's unbelievable, really unbelievable. You can see a bit of the reflections if you look here. There is a slight curve, but I think Florian and myself, we managed to keep that under control. So I would really say this is a valid result with 16 stops that we can count alone from the waveform plot above the noise floor. And this, we have never seen this so far. Never. Not even with the Arri Alexa 35.
which so far has been the best camera.
The best camera we saw. It had 15 above the noise floor, and then a 16s and 17s buried in the noise floor.
Now, of course, my first question is, is there a lot of noise reduction applied? Because we know that these results can be tricked by an excessive amount of noise reduction.
And the quick answer is no. There's not a lot of noise reduction applied. It's simply the capability of this sensor. And because you will see later when we talk about the dynamic range results with IMA test, we can show this as the next image. But also when we look at the latitude tests, I mean, the image behaves amazingly fine. Let's have a look at the IMA test result. Yeah. And you can see here, based on this Xyla 21 shot that we took, you always see like the medium score, that's the signal to noise ratio of 2. It counts 16 stops at a signal to noise ratio of 2. That's one stop more than the Array Alexa 35. Just to mention that.
And the signal to noise ratio of 1 is 17.2. So it's exactly
what DJI claims.
It's exactly their claim. Amazing.
Wow. I mean, DJI, hats off. Hats off to you. But even more amazing, you see also slope-based dynamic range, 18.3. That's the maximum IMA test could discern from that image. Maximum patches it could see. 18
so that's
stops.
Basically also including what we deem unusable, right? Which is
sure.
in the noise floor.
That's in the noise floor and so on. But still, this was the number of patches it was able to discern. Plus, look, talking about noise reduction, I mean, here the issue is also that typically, if we have a lot of noise reduction, we always look at this graph here. That's the noise spectrum graph. And it shows basically the frequency on this axis, meaning if you go to higher resolutions, if there's a lot of noise reduction, you cannot easily discern a black and a white line anymore. So that gets smeared out. But here you see the DJI Pocket 4P retains very high amplitudes at very high frequencies. Means this is a superbly detailed 4K image with very little, if any, noise reduction at place, and we get this result. I mean, how good can it get? Amazing. I've never seen this. We tested, 70 cameras so far. This I have never seen.
Were you surprised? I mean, like also when you heard about the LOFIC technology, did you read a white paper and you were like, oh, wow, this sounds great? Or was it more like, I had no idea what to expect?
No, actually, when I read about the LOFIC technology and this idea to store the highlight, like the overflow of the sensor with a special capacitor on board of the sensor, I was like, wow. I mean, this sounds amazing. Amazing.
And for me, it's just interesting that, I mean, it's also a sign of the times that the first device that we get is something with a very small sensor, because
it's a 1-inch sensor, guys.
Yeah.
It's not a full frame, whatever fancy sensor. It's a 1-inch sensor.
But it also shows, as you mentioned before, where the money goes, right? Where people actually spend money now at these devices. I mean, we keep talking about large sensor cameras in a way, but the reality is this is where manufacturers actually make money now, smartphones and this.
Yeah.
I think also I have heard that the Osmo Pocket 3 has been the most popular DJI product that has ever been sold.
Yeah.
That's not confirmed, but I have a good source that should know. And I wouldn't be surprised, why this much effort goes into this category now.
Yeah, and we also have to say, I mean, you mentioned it before, I mean, all the research money goes to like small sensors, smartphone sensors, blah, blah, blah. So I'm not sure we will ever see such a sensor in a full frame camera because the numbers probably don't justify it. But let's see.
It's a good question,
having my dream would be like, this original Blackmagic Pocket Cinema camera, the small one, the original one with the 16mm sensor. I mean, putting this sensor in such a small camera where you can change lenses and maybe also even have an internal RAW mode, you can use some speed boosters on it. Wow. I mean,
well, what
could be
is
amazing.
Just
use this sensor in a swappable lens camera. Also fine.
Yeah. At some point, it's a question of why do you need a large sensor, to be honest? I mean, there's still a lot of reasons, of course, with depth of field control,
image characteristics, lenses.
Low light capability, though, for example, is one area where it's getting less relevant. We already see a lot of those things being exceptionally good in low light, where it's actually not as much difference as you would expect to the large sensor, right? So, and the depth of field thing, for me is a question if, like once the processors will be fast enough in these things to fake the depth of field in a convincing way.
Yeah, I mean,
being
a puristic filmmaker, I don't love
me too. I don't love it too, but I'm just saying, like,
because I like to use old lenses. I like to use anamorphic lenses.
I do too. But the question is for the average user.
Sure.
Imagine they can just select. Oh, I want this to look like a Cook. Something from the 70s, and then
you dial it in. That's it.
You dial it in, and it looks convincing. And of course, if you pixel peep, you will see the differences to the real thing. But I can see this on the horizon already, this type of thing happening. So I think it's just something we need to brace ourselves for.
Yeah.
Having said that, I think I hope that because one of the LOFIC sensor technologies now is also, I mean, basically we know of Sony and OmniVision making these sensors. Maybe there's more, but those two make LOFIC technology sensors now, the small ones. Sony makes all kinds of sensors. So why shouldn't they apply their knowledge to the larger version of it at some point, right?
Yeah.
Because
it's all about numbers, I think.
It's all about numbers, and you also have to think about, what is a reason to upgrade a camera these days? There's less and less reasons.
Yeah.
We've just seen with the FX5 release, of course, that's a big jump for Sony because of the internal RAW. But what would you make, let's say, buy a successor to a Venice, why autofocus? I don't know if that category needs it, but a sensor like that in full frame,
that's a different story.
That would be the difference.
We have to be honest here. I mean, I'm using my Lumix S1 since 7 years? You use your FX9 since how many years? Have we upgraded our cameras? No.
It's good enough for 90% of things. I think that's the way a lot of people think now. Cameras are so great now.
Yeah.
So, of course, they need to differentiate. But again, the money is in these small devices. So I think we will probably see the LOFIC technologies in smartphones long before we see it in larger sensor cameras.
Yeah.
And that's going to be, it's going to be a challenge, actually, because you will literally be able to shoot higher dynamic range images with a device in your pocket than your professional video camera.
Yeah. That's why I say put this in a small swappable lens camera body. The same sensor. I don't need a bigger one at the now.
Yeah.
But Nino, you said before, dual gain technology comes at the expense of rolling shutter. Now let's have a look quickly at the rolling shutter of the DJI Pocket 4P. And also there you see this wide sensor has 11 milliseconds of rolling shutter. That's quite good. That's really good. So nothing to complain about.
It's good, but it's not great, right?
It's good, but it's not great. We've seen cameras already that have like 7 milliseconds or even 5 milliseconds.
For example, the FX5 seems to be. We haven't had it in the lab test yet, but from what we're seeing, again, we haven't tested it because Sony wants us to test the production version of the camera. But, like some other trustworthy people in the industry who have tested it get a very good result.
Yeah, for instance, the Sony A7R6 that we had in our lab test also. If you turn off the dual gain, you also get like 7 milliseconds. That's very fast.
According to a source that our friend Philip Bloom has, who was on last week's episode, the hardware, like the sensor and the processor should be the same. Sony says it's something different, but let's see. With the quad Bayer thing. Mathematically it would work out. I'm just saying in terms of how the megapixel that they claim. But we will see when you have it in the lab if the results are comparable.
Yeah, true. So you can see very nice rolling shutters actually. And again, I mean, this is a gimbal camera with 11 milliseconds. So you could actually on a gimbal afford higher rolling shutter values without issues. But
although having a small sensor also usually means lower rolling shutter speeds, right?
Typically, yes. Yeah.
Because let's say you took that technology and just made it bigger, then you would have a lot higher rolling shutter, no?
Probably higher rolling shutter, because the length of all the connections and everything becomes larger. So,
but this, correct me if I'm wrong, is maybe also something that is affected by the processor that is dealing with
the processor, how much heat you generate, reading out the sensor, and so on and so on.
You could probably have a faster processor and a larger camera body.
Yeah, with good cooling that could
deal with it better.
Yeah, true.
Okay, interesting. Yeah.
Yeah,
Good.
and then of course the big question is always when you see a superb waveform plot of the Xyla chart and you see a superb image test result. Nevertheless, the proof of the pudding is always the latitude, the exposure latitude. And you know what we do there? We basically set the base exposure and then we try to overexpose as far as we can and then underexpose. And in both cases, we always bring it back to the base exposure and then look at the noise, the color profile and everything. And then you see how quickly an image falls apart. So before you think this is better than an Arri Alexa 35, let's have a look at the latitude results. And of course, it's in the lab test article, but probably let's move over to DaVinci Resolve now. And this is the Luna. We are going to talk about it in a second. Let's go to the DJI Osmo Pocket 4P. And if we have a look at this wide sensor first, our base is always this image. And this was from the Arri Alexa Arri Raw base exposure. And then the subsequent waveform that you can see down here of this base exposure, we always use this as our reference and then also expose, for instance, the 4 stops over in the same way. You see the waveform here, the base exposure in the same way, and then from there onwards, all the other exposures.
Let's just quickly address why it looks so different. I mean, there's a lot of time in between, but also it's
good point. Yeah,
please. It's a wide-angle camera that's much closer to me, so maybe you can show those images because we talked about. Usually, we use a 50mm or 50mm equivalent on those cameras. So, of course, on the Alexa 35, it was a 35mm lens because 1.5 times crop approximately. And for the Osmo Pocket 4P, it's a fixed 20mm. So we literally had to move the camera much closer. So, of course, that distorts what's in front of the camera. And that means the face looked simply different.
Yeah. We had to move super close, as you can see. No?
Exactly.
That's not ideal.
Yeah, it's not ideal, but there's nothing we can do. It's a fixed lens camera. So we have to deal with that. And it's probably something, like we have to get used to also with other tests in the future, because now that we have the setup, we can also test drones and stuff like that. So basically that's why it looks different. And the way what Florian came up with is quite nice. So it's a little matte box from Tilta, I think, and you can put in the ND filters to go through the whole exposure range.
Exactly.
This is connected to the Blackmagic. What is it called? Dock. Blackmagic Dock, just Dock, Pro Dock.
Yeah.
That's actually made for the iPhone 17 and 15, 16 Pro. So you can actually have HDMI out and all, even like timecode and channel log and so on. But this also works with the Osmo Pocket 4P to get a clean video signal out onto the screen, right? Correct me if I'm wrong. So you can judge the exposure properly.
Yeah, you can look at the waveform plot, judge exposure and everything. Yeah, and that's superb.
And so that worked quite well. And that was the setup. Of course, the light. So basically that's how it works.
What we have to say here in the lab, we use the strongest studio light, and still we were not able to clip or come close to clipping the red channel on Nino's front end. Here.
We need to get even stronger lights.
We need to get stronger lights. But what we were able to deduct from comparing the Xyla 21 waveforms, RGB waveforms, to this, how your front head was exposed, we were able to deduct there was about 1 to 1.5 stops room in the highlights still before the red channel would start to clip. And this we have also mentioned in the article. And quite amazingly actually, moving back to DaVinci Resolve, you see here the base exposure. So we can overexpose 5 stops from the base exposure until the forehead starts to clip, the red channel. And with the DJI Osmo Pocket 4P, no need to go through 3 stops unders, 4 stops unders, something. Let's jump directly ahead here. To 4 stops under, we are at 9 stops of exposure latitude without using noise reduction. 9 stops. That's something.
Can you play it back?
Yeah, that's something only recently. Let me just fix this here because then I can play it back continuously. That's actually something that only the Canon R1, for instance, managed to do in RAW mode last year, or the Sony A9 III managed to do 9 stops of exposure latitude. Only recently, consumer full-frame cameras were able to do that without any big artifacts, stripes, horizontal lines, whatever. And this is not even noise reduced.
Crazy.
Yeah? So it's actually crazy good for that. And now let's move further. We can go down now to 5 stops of underexposure. We are at 10 plus stops of exposure latitude.
It looks brownish
and
suddenly.
You see, interestingly, a shift happens between those two. At 9 stops of exposure latitude, colors and everything is still okay, but then noise starts to kick in. At 10 stops plus.
That's why I started rolling my eyes, probably.
Yeah, that's why you're rolling your eyes. And you can see the noise is there. And what the problem is, if you then noise reduce this, posterization and bending starts to occur. So actually, I think it's not so much the limitation of the sensor, because the noise profile still looks okay, actually. Not so bad. But if you further add noise reduction in post, then you get bending and posterization. And we show this image also in the lab test. And that shows the limitation of using a 10-bit codec on a super wide dynamic range camera.
Okay.
For comparison, we talked about the Arri Alexa 35. They on purpose are using a new flavor of the Arri RAW codec in that camera, which has 13 bit depth. And the exact explanation for this was they wanted to avoid in certain situations that bending posterization can occur on such a high dynamic range camera. And so the real limiting factor here is the 10-bit codec,
Crazy.
not so much the sensor actually.
Yeah.
And the interesting part here is, of course, now again, the Arri Alexa 35 managed 12 stops of exposure latitude. And here we see the limit at 10 plus. But I mean, come on. There was only one consumer camera full frame so far that managed to reach that. And that was the Panasonic Lumix S1 II last year.
Amazing.
And the Arri Alexa Mini LF, the full frame one, also reached 10 stops of exposure latitude. So
theoretically, if they made a pro version of the Osmo Pocket 4P, like a Pro,
a Pro,
Super Pro, Ultra Pro, Ultra, see, we could have a 12-bit codec inside.
I don't know if the sensor is capable of having a 12-bit readout. That would be interesting. So that's where we would need to know the sensor and what the capabilities are of the sensor.
They probably didn't even think about this because
I don't know.
Just for those small devices. Yeah.
Typically 12-bit is possible in video mode.
Okay.
So if 12-bit would be possible, the results probably would be better. Even.
Incredible.
But we had 10 plus stops of exposure latitude. And this is not even using noise reduction. Still, it's not so bad actually. Amazing.
Wow. So what does that mean, Gunther, in terms of where the result of the Osmo Pocket 4P shows up in our camera databases?
It will show up on top of the list, probably.
For everything?
Yeah,
except for rolling shutter.
Yeah, except for rolling shutter. But the IMA test result will be on top. The latitude result will be second behind the Arri Alexa 35. So a proper cinema camera can still beat this device.
barely
beat this device, but you know.
Incredible. And now a quick commercial break. This episode of Focus Check is brought to you by Hollyland and the Lark A1. If you've been meaning to start capturing better audio on your phone but didn't want to wrestle with menus or pairing, this is the one. The Lark A1 is a wireless lav built for people just getting into this. You plug the USB-C or lighting receiver straight into your phone, clip it on the mic and you're recording. No app required, no Bluetooth and no setup ritual. It is tiny, 8 grams under a centimeter thick, so it disappears on a collar. You get real 48 kilohertz 24-bit audio, a charging case that holds up to 54 hours and up to 200 meters of range line of sight. There's a Lark sound app if you want to dig into gain and EQ later, but you genuinely don't need it to get going. This is the mic for grabbing everyday moments. The walk and talk, the quick piece to camera, the trip you didn't want to take a full kit for. Just know it's a phone mic and not a full camera rig. The Hollyland Lark A1 starts under $70. Follow the link in the show notes to check it out. And now back to the show. We talked about the Osmo Pocket 4P.
Yes.
And of course, let's talk about the big contender, the Luna Ultra.
Yeah.
But this paints a little bit of a different story.
Yeah. I have to say, I was very excited to move into the Luna Lab Test. And yeah, we looked at the rolling shutter. Nice, very similar result. By the way, we have not covered the tele camera on this one.
Oh, let's
tele
actually
camera
talk
is
about
also
the
good.
Yeah.
If you look at the tele camera of the Osmo Pocket 4P, I think no need to show a lot here.
Yeah.
Of course, the image looks much less distorted. We have a 60 millimeter equivalent length now. That's fine. And we get also for the tele camera, we get 8 stops of exposure latitude, which is really good.
But it's not a LOFIC sensor.
No, it's a normal 1/1.28.
Maybe show just
sensor.
one result of the latitude.
We can go.
So that's actually surprising because I mean they say this has 14 stops, I think, of dynamic range.
Yeah. You can see here now the tele sensor. That's 3 stops over. So you can see there's about 2 stops difference in the highlights between the wide and the tele camera. So you can only overexpose the tele sensor 3 stops.
Okay.
Yeah. And then you go down to base exposure level like here. Looks fine. Virtually no noise. And then we stop down to, let's say, 3 stops under. We had 6 stops of exposure latitude.
Still looks okay.
Okay.
There's noise, but it's completely manageable.
But the noise looks fine. This is not noise reduced in any way. 7 and let's say 8 stops, the limits. This is really the limit. You see there's lots of noise and then you have to use noise reduction in post. But you can still sort of salvage it in post. Yeah. So, I think here's an example. No, this was this one here. It's borderline, but there are no horizontal stripes, no vertical stripes. And you could apply maybe a bit more noise reduction and the skin on your dark side still sort of cleans up. So this is still borderline at 8 stops, but fine. It's a good result.
Okay.
I mean, still there are cameras out there, full frame cameras that have 8 stops of exposure latitude.
What does the IMATest result say?
Yeah, IMATest says 11.6 stops, I think. Let's have a quick look at that. Here's the write-up of the 2 cameras. You can see the right result here. 11.6 stops at signal-to-noise ratio of 2, which is pretty good, like 12.9 at 1. And you see also here not too much noise reduction, so actually pretty good result.
Okay. So even though this is not a LOFIC sensor, and of course it's a bit of a challenge, what I mentioned, like switching between D-Log 2 and D-Log, it is definitely not a bad match for the main sensor, right? Because that was my biggest worry, that it's like so
completely
different
off.
that you can't actually use them together properly. So that's okay.
Very nice. And what I like about it is DJI doesn't overdo it with any noise reduction or anything. So you get a real solid base image out of this camera that still allows lots of flexibility in post to push it around. That is fantastic for such a small device. I mean,
we've never really lab tested the drones, but we know from the past, from experience, that I think they've just probably learned a lot, because there have been drones that had an excessive amount of noise reduction, and then kind of they listened, and then the higher end versions did much better in the future. So, but now it's time to move on to the Luna Ultra.
Yeah, moving now to the Insta360 Luna Ultra 8K. We looked at the rolling shutter results of both cameras in a very similar range than the DJI Osmo Pocket. For Pro, so around 10 milliseconds, even 9, going a little bit lower. Very nice. And then we moved on to the dynamic range results. And here the issues started because I can show you maybe this quick result here. We were not able to get a meaningful result running the files through IMATest. IMATest calculates the signal-to-noise ratio for every patch of the Xyla chart. And if you move down to the shadows, if there's too aggressive noise reduction at play, then IMATest cannot discern any longer the signal and the noise value properly. And you see, for the wide camera in 8K H265, but also for the 4K modes, it's a similar result. You see all the values are 13 stops. Signal-to-noise ratio 2 is 13, signal-to-noise ratio 1 is 13, slope-based TR, total number of patches, 13. So that means it's super aggressive noise reduction at play, where IMATest cannot discern the stops anymore in the shadows. And you see it also here in the noise spectrum graph. Again, remember, moving to higher frequency, we want still a high amplitude. Otherwise, a black and white line becomes blurry because of the noise reduction. You cannot discern the black and white line anymore. And you see, even at very moderate resolutions already, the amplitude drops to 0.2 and below. That means this is not an 8K image. I mean, this is iLog. at ISO 400. Yeah, so we specifically asked Insta360, our contacts there, what is the native ISO value for each of the cameras, and for both it is ISO 400. And they also confirmed ISO 400 is the value that should give the best results for iLog. Yeah, that's why we use this. And you see completely washed out, super aggressive noise reduction at play. And the same also for the tele mode. But the interesting part is all the 4K modes on the Insta360 tele modes are the same, super washed out, super aggressive noise reduction at play. But obviously, did they forget? I don't know. On the 8K tele mode, there's only little noise or moderate noise reduction at play. And you get a meaningful image out of that. So on the tele 8K mode, iLog, we get 9.71 at signal to noise ratio of 2. It's about 2 stops less than DJI. And we get 11.1 at signal to noise ratio of 1. And you see it also in the waveforms. You see here the tele camera waveforms. In 8K, you see the waveform plot of the 8K. You see quite some noise in the noise floor. Yeah. And you see an 11th stop that sort of sticks out from the noise floor. That's the 8K mode. But the 4K mode next to it, same tele mode, super clean, noise reduced to depth. And it shows, unfortunately, also in the images, if we go to the latitude test.
So that's funny. Did they forget to apply noise reduction
for
in
this one mode?
8K telephoto mode?
I'm even afraid to mention it here in this podcast because the next thing Insta360 will do, they also apply the aggressive noise reduction to the 8K tele mode.
We've had this before.
I hope not.
We've done reviews, to be fair, also with DJI cameras where they enhance, which is great, but literally a review was done and then the firmware update
was coming
and they fixed it. So the whole review is kind of obsolete. But let's hope they fix it. But it's interesting. I mean,
what they should fix
looks like a very strange omission. But I mean, fix.
No,
they should actually
fix the other modes.
Exactly.
Not this one. Leave it, please.
They should just leave this one and
please leave it.
Just get rid of all the aggressive noise reduction in all the other modes.
Yeah, it's super aggressive noise reduction. You cannot even do anything about it in camera. There's no setting or anything.
Yeah.
Of course, everything was recorded in the high bitrate mode that we have there. iLog,
Now, what we have to say, of course, those are lab tests. Those are not real-life images, but what we have seen in practice with the Luna Ultra is that you have extremely washed out. You don't have a lot of detail in iLog, in iLog 8K on the wide camera.
Yeah.
And it's a problem. I mean, they need
to fix. They
need to fix this. There's something wrong. It's just way too aggressive. Maybe they try to have clean images, but it's almost like
also for low light. Maybe they wanted to have it clean.
Turn the wheel too much because it's like
way too much. I mean, come on.
Yeah.
And I mean, this is a chart, but now let's look at the exposure latitude of the Insta Luna. So I'll switch over to the Luna here in my Resolve. And let's start again with the wide camera. Yeah, you can see here, you can overexpose 4 stops, the Luna. That's fine. Then we go to the base exposure, wide camera, 8K. Yeah, so we talk about the 8K base exposure mode. And now I just fix it here that we can have continuous playback. And you see already in this mode at the base exposure, for one, not many details. Look here, you can barely read this data color spider text here. Plus, you have a lot of noise already in this mode. You can see on the edges of the frame here already a pinkish noise creeping in. Also the shirt at base exposure is rather noisy despite the aggressive noise reduction. So very strange. And then if we go further, for instance, let's go down one more stop. So we are at 5 stops of exposure latitude here. We had 5 stops at 1 under. And now again, I fix it that we can have a continuous replay. At 5 stops exposure latitude, you already see a strange behavior that you see noise and then it's aggressively reduced. And then again, the noise pops up because that's a longer codec. Every 15 frames, also on the sides, you see it. Every 15 frames, you get again like a I-frame image, the full image. And then from there, you have obviously a very aggressive temporal noise reduction. So towards the end of the frames, you get this completely posterized washed out image and also pinkish noise creeping in at 5 stops of exposure latitude
Which
only.
is not a lot. Yeah.
It's nothing. And now if you move down to 6 stops, and you see, also look at the right side here.
It looks like there's another person moving there.
Yeah, there's something moving in the background. Like,
it's almost like, it's like a ghost.
Completely.
That's crazy.
I mean, that's crazy. This is a completely unusable image at 6 stops only in the wide camera.
Incredible. I mean, are there better and worse ways of in-camera noise reduction in your opinion?
Yeah, sure. I mean, to me, this looks like too much temporal noise reduction. You can apply spatial. So temporal means that you look at successive frames and from frame to frame, you deduct where the noise is. And then you try to get rid of this noise, like the motion-induced noise. So in a static image, it should work very well, but you see it here. Posterization, you can see large blotches of chroma noise. And you see the noise reduction that plays almost like a pumping of the image going back and forth.
So maybe Insta360 only stole the wrong people from DJI and not the image scientists, because I'm staggered how somebody could not see this.
Yeah. I'm also wondering about all the reviews online. Did nobody see this? I mean, come on. They always do it in super bright light maybe, and then you don't notice. I have no clue.
Yeah, I don't know how many actual unbiased reviews honestly are out there yet. Of the Luna Ultra, but it seems like they
and imagine
been spending a lot of marketing money, let's put it that way.
We are here at 6 stops of exposure latitude.
Yeah.
The same wide camera, DJI Pocket 4 Pro, shows no noise at all, nothing, and you can push it to 10 plus stops. So we can deduct the wide camera on the DJI Osmo Pocket 4 Pro has 4 stops more exposure latitude than the Luna.
Incredible. So we talk actually about literally devices there's barely any devices that go as much head to head as those two, with really no other contender.
Yeah.
I mean, I can't think of any other device except for the Extra brand, which we know is probably just a front for DJI. But in terms of, there's not really another hardware from another manufacturer that competes with the two. But the difference is in the quality of the sensor,
of the image.
Couldn't be, and the resulting image couldn't be more staggering, actually.
Yeah. The difference is staggering.
And I mean, those are partially things that are, at least when let's put it that way. The DJI result is exceptionally good because of the LOFIC sensor.
Yeah.
The Insta360 result is exceptionally bad. Mm-hmm. Not so much because of the sensor, because it's a normal sensor, but the more like pipeline. Because of the how the image pipeline has been implemented in a bad way.
In a very bad way. Yeah.
So this is something that theoretically could be fixed in firmware.
Sure. I mean, we talk about the iLog image now, not about the other modes.
We
the
only
standard modes probably
stuff. Yeah. So it will never match the Osmo Pocket 4P. This will always be a much better image because of the LOFIC technology, but at least it could be much more usable.
Yeah, reasonable. And you see it, the funny part, if you look at the tele camera, remember, we said that for some reason in the 8K mode, Insta360 maybe forgot to implement this aggressive noise reduction, or I don't know what the reason is.
Maybe they don't have enough processing left. Could that be? Does the 3X need more processing? I don't know.
Maybe. I don't know. I don't know what it is, because the same 8K image with the wide is a catastrophe, and the same tele 8K image does not have as much noise reduction, and it also looks so much better. I mean, have a look here, for instance, now at the wide camera. Yeah. This is now the 8K wide camera. I always skews up this. And you see, okay, that's 4 stops over. You can overexpose by 4 stops. Fine. We go to base. Remember the base image. Yeah. The base image was already very noisy with the wide camera. This is sort of okay, and the noise also looks fine. There's not this pinkish large blotches of noise appearing. And if I just fix this image and replay it all the time, you can see very nicely here, the noise is there. You can see also horizontal stripes, but the noise doesn't look ugly, or you don't have this pumping background that we saw already with the base exposure image actually of the wide camera.
It looks like something that could be fixed with noise reduction.
And you see here the 5 stops exposure latitude image. You see these horizontal stripes appearing already. Yeah.
It's like a flicker.
Yeah, you can still noise reduce this in post, but you will see this horizontal stripes. And then if you go to the 6 stops under image, then it's completely game over. Yeah. So again, we can say that the tele, but the noise at least sort of still has a quality, and you don't have this excessive pumping of the temporal noise reduction in the background. So nevertheless, the conclusion on the tele camera is similar. We can push this to 5 stops of exposure latitude versus 8 on the DJI. So on the wide camera, we have more than 4 stops difference in dynamic range and exposure latitude. And on the tele camera, we still have 3 stops of latitude difference.
Yeah. Very interesting.
Which
I mean,
is
of course,
still huge.
Yeah. It's a staggering difference between the two. I mean, I'm just for the sake of completeness, of course, we have to also mention that it has some things going for it, like this removable
we're
screen.
not talking about usability
at all.
anything.
We're only talking about the quality,
the pure image
of the image quality, which in my opinion is always the most important thing, right?
Sure.
At the end of the day, but still, I mean, it has some advantages over the Osmo Pocket 4P. I just want to put it here for the sake of completeness, because this is definitely a smarter way to integrate a remote screen. So let's just talk about the price differences, because that's even more interesting. So the Luna is 729 euros, and the base, this was just released today, the base price of the 4P Pro is 600.
Oh,
so it's 130 cheaper than the Luna.
Yeah,
but it has a much better sensor, much better quality in general. So that's just staggering to me. So I guess, Insta360 probably needs to match this price at least to remain interesting in this case.
Definitely.
Because we know, of course, I mean, for sure, this LOFIC sensor is much more expensive to source than what Insta360 built into the Luna.
Yeah.
And maybe that's just my speculation. I mean, DJI, we talked about before that whole weird launch of those two, right? There was like, I know people were testing the Luna, and then they had a date, and suddenly Insta360 announced, well, actually, it's out now, or it's out next week, and everybody was like, well, my video is not done.
No.
I think Matti Hapoya talked about this in his review, because he was part of that crowd. But DJI equally played a weird game, because they released it in China already, 1.5 months ago, and then they released it a month ago in the rest of Asia. And only now it's released in Europe and not the US, because of the challenges they have there in terms of the market. They're not allowed to introduce new products, unfortunately, there, even though we know you can, like order it from third parties for more money, but it's officially not available in the US. And part of the reason for that might be, that's my speculation, is that DJI always wants to announce a product and have it immediately shippable.
Available in the shelves.
And because of the sheer amount of how many they sold of the Pocket 3, we know there was a lot of pent-up demand for this one. But maybe, again, speculation, because Insta launched this earlier, they felt forced to launch it at least in some markets before they actually wanted. So they launched it in China and Asia. So they had something in the market, but they didn't have enough units to ship to the entire world. They had to build them. And I'm sure, actually, on the day you see this, that it's almost immediately shippable now, because that's probably what they're working on to stock up the warehouses. That's my speculation, because so far, with every DJI product, there's rarely ever been any DJI product that is not literally ready to ship the second they announce it. So also in terms of review units, we've almost rarely gotten unfinished hardware from them to test, even though it was way before embargo dates. So it's almost always already the finished packaging. So the hardware is done, right? So by the time you get it. So that's just my speculation. That's why they moved into this way. It was partly competition, but also partly because they probably didn't have enough of them in their warehouses to ship out. That's just, like my 2 cents on this whole story. But so what's our summary? What's your summary?
Yeah, I mean, if you're looking for the perfect image quality, then it's a complete no-brainer. The DJI Osmo Pocket 4 Pro is the way to go. Of course, pure image quality is not everything for everybody. If you're just interested in some of the other usability features, the removable screen, whatever, Luna is maybe also not bad, but they have to fix this 8K and 4K over-aggressive noise reduction thing in iLog. This is completely unacceptable.
And the whole 8K claim is kind of pointless, right?
It's completely pointless. With that noise reduction, it's pointless.
The 4K image out of the Pocket 4P looks much
more
sharper
detailed than the 8K.
On the Luna.
Yeah, exactly.
Luna. Yeah. Okay. Well, there you have it.
It was an easy one, no?
Not an easy one, but I think it was great that we talked about both of them. Both of the lab tests from Gunther and Florian are now online on CineD.com. Of course, linked in the show notes. Just give them a read through, check out all the results for yourself. And this video goes with both of those lab tests as well. So, and leave a comment. We always highly appreciate your comments. Please let us know what you think. Let us know what camera you decided for. We were honestly blown away by the result of the Osmo Pocket 4P, and we just hope that this technology will find its way into many, many other cameras, whether it's larger sensors, smartphones, it doesn't matter, because for us users, it will make a huge difference.
Huge.
And it seems like in the future, correct me if I'm wrong, but there will not be, like, bad dynamic range will become very unacceptable in a way. You know what I mean?
Yeah.
Because as soon as you see this moving into more devices, the others will look so much worse. That this LOFIC technology basically has to go into everything. Because I don't really see a downside to the technology, right? There's not really any...
I mean, the one thing is with the 11 milliseconds of rolling shutter, you're a little bit limited with the frame rate. Yeah, so you can go to barely 90, even lower than that frames per second. That's also why the Osmo Pocket 4P only works with the LOFIC up to 4K 60. The higher frame rate modes use something else to read out the sensor. But
that might be down to processing, right?
Could be processing, but could also be in general maybe the way how the charges are stored on this integrated capacitor. You need to read it out at a certain point, and could also be that limitation.
Okay. Well, we will see.
Yeah, we'll see.
But I'm sure
4K 60, I mean, what else? That's already very much.
And I have to correct myself. I said on one podcast before that this is the first device with a LOFIC sensor. That's not correct. Philip told me that there's a smartphone that has a LOFIC sensor already. I forgot the brand. It was a Chinese brand, which is not very widely known here. But there is one already in the market. But of course, I mean, this is probably the first mass product that's available almost globally except the US. So let's see.
Yeah.
Thank you, Gunther.
Thank you.
Thanks everybody for watching. As Gunther said, please leave a comment either on this article or email us at podcast@cined.com or the YouTube video. And don't forget to like and subscribe, and also subscribe to your favorite podcasting platform on Spotify or Apple Podcasts. We appreciate it. It will help to keep the lights on here at CineD if we have more subscribers for this. Thank you and see you soon.